of the first occurrence in a string. So for this problem, we are giving a haystack and we are also giving needle string. So we want to find the pattern, but we want to find the first index of this pattern. So for example, if it is a shed and it is just coming from here inside of the haystack, so the index is going to be 0, so we're going to just return 0. If we cannot find it, we're going to return a -1. Definitely we will not use brute force to solve the problem. We're going to use some string matching algorithm to solve it. So the first one, and for today I'm going to use the KMP to solve the problem. And for the KMP, normally we're going to use a next array, or you can use a pi array. It is called pi. But I'm going to use a next array. So I'm going to define a next function, and inside I'm going to get the next array. I'm going to prepare a next array, and finally I'm going to return this next array. Yeah. So today I'm just gonna use a easy way to solve the next array. So I'm going to prepare a next array. So the first index is going to be a dummy index. It's going to be helpful for us to get the final calculation. So I'm going to prepare a -1. And for the j, it's going to also be starting from -1 as well. So this is easier to write for the KMP for calculating the next array. And we need to know that because of this KMP, the time complexity is m plus n. So instead of m times n, because m times n is going to be brute force. So this means also for the KMP, for the index I inside of the haystack, there will no backtrack. It always goes forward. Yeah. So this is very important for writing the algorithm. So this means if we are going to design this I, it is basically for the haystack. Because there's no backtracking, it will always goes forward. So here, yeah, it's for this I. So it's gonna start from 0 to n-1. And for this j, we're gonna use a while loop to check. It must be more than or equal to 0. And we're going to check the pattern matching if it is equal to or not. So if si not equal to sj. So this is just for preparing the next array. So for example, this s is not equal to a, and this a is not equal to d, and what are we going to do? Yeah. So if they are not equal, basically we can prepare the j gonna be equal to the next array with this j. And if they are equal, or if we go out of the array, so this j gonna plus equal to 1, and the next array gonna plus j. Yeah, so this way of writing the next array gonna be really easy to understand. If you basically you need to understand what gonna be KMP, and then you should find a way to writing the KMP algorithm. First of all, it's going to be the next array. And now let's just have a check, and I'm going to explain why we're going to write it like that. Yeah, so first of all, let's just check the next array. Yeah, because this is a function, let me just put the needle inside, because this next array is just for preparing the pattern, and this pattern going to be the needle, because needle is a pattern. Yeah, so let's just check what is inside for this pattern. So for the first example, it is a shed. So for the next array, the first one, it is just a dummy space. We just put it there, so it's going to be a -1. But for this s, as there's no matching, as it is also the first one, so we're gonna put a 0. Yeah, because definitely currently this I equal to 0, and this is j. Yeah, let me just check it. So for I equal to 0, because this j is a -1, so there's no checking of the while loop, but this j gonna plus 1. So if this j plus 1, so j gonna become 0, so the next dot append gonna be a 0. This is why it is there. And next, so we're gonna check this I. So I gonna be equal to 1. and S1 not equal to S0 because this A is not equal to S. Yeah, so S1 not equal to S0, A not equal to S, so this is J gonna be next to J, so this is J gonna be -1 because J is equal to 0 and next to J gonna be a -1. If J is -1, J plus 1 gonna be 0, this is why for the next position it's gonna be 0 as well. Yeah, so this is why we're gonna write it like this. So this is exactly for calculating the next array, and this is much easier to write. And for the next one, I gonna be equal to 2, right? And this J gonna still be 0, and this Si, this D not equal to Sj, Sj, J is 0, D not equal to S, and J gonna equal to the next J. Yeah, so the J equal to 0, so J gonna be -1, and J plus 1 gonna be 0 as well, so we just put a 0 at the end of the next array. As we can see, this is just for calculating the next array. So if we finish calculating the next array, basically we've already solved the problem. Yeah, because next it is just a string matching, and it is just similar to calculating the next array, and we just need to put the needles inside and we get the next array. And let's do some preparations. So I'm gonna use S and pattern. So S gonna be the haystack and pattern gonna be the needle. Now I'm gonna prepare two variables. It's gonna be the length of the length S and the length of the pattern. I'm gonna prepare a pattern variable J, pattern index J gonna be equal to 0, and let me just copy the same code because they are similar. So for the pattern matching from here, this I gonna still be starting from this S, so this S is just the haystack. Yeah, and here we still gonna check this index J. It should be more than or equal to 0, and Si, if it is not equal to the pattern, here it's not S anymore because currently we are going to check the pattern, so this one will be changed to pattern. So if they are not equal, J gonna still be updated to the next J. So this is what we are using for the next array. Yeah. So this is a part of the KMP. The first part is gonna be the next table. We finished calculating the next table. The second step is just the string matching by using the next table. Yeah. So currently, this is J gonna be updated to the next J, and if it goes out of the while loop, this is J gonna still plus equal to 1. But after that, we're gonna have a check. This is J. If this is J equal to M, basically, it means we've already found it. We've already found this shed. Currently, for this is J equal to M, M equal to 3, and this is J equal to 3. This means we need to return the final result. It's gonna be I minus J plus 1. Why it is I minus J plus 1? Because normally we're gonna not use this J plus 1, but here in our algorithm there's always be a J plus 1. Actually it should be J minus 1, so it should be I minus J minus 1. So it should be I minus J minus 1. Yeah, so that is why the final result is gonna be I minus J plus 1. If we didn't find the pattern, we're gonna return a -1. It is just according to the description. Now let me just run it and submit it to have a check. Yeah, as you can see, it works and it's pretty fast. Why are we gonna use KMP? Because KMP is the best string matching algorithm. Yeah, it is the best. It is much better than other algorithms like the len function, like the rolling hash, and of course it is better than the brute force. Currently the time complexity is gonna be m plus n instead of m times n. Yeah, so this is why we're gonna use the KMP. And actually I think if you cannot remember it, it is okay. You just need to understand it first, and then you're gonna try to remember it. Maybe if you didn't remember it, at least you needed to understand the next array. and then you can use the next array to finish the 3 matching because they are really similar. Yeah. So I think that's all about it. Thank you for watching. See you next time.